Hello my dear students, welcome to WBJEE YouTube channel. So today we are going to solve some problems from relation and functions, and this is for class 12. So let's start. So problem number 1 is saying let f such that R to R be defined as fx equal to x to the power 4, show that f is neither 1 1 nor 1 2. So f is defined from the real numbers to real numbers and fx equal to x to the power 4. So first recall that a function fx is 1 1 if and only if fx equal to fy implies x equal to y, and a function is onto if and only if for all y belongs to codomain there exist a x in domain such that fx equal to y. So we will exploit these two conditions to check whether this is 1 1 or 1 2. Let x comma y belongs to R, the set of real numbers, because it is defined on the set of real numbers. So and assume that fx equal to fy. Please follow the way in which I am solving these equations. This is the standard way to solve. You have to do like this in exams to solve these problems. So what does that imply? This implies that x to the power 4 equal to y to the power 4, and we will check that x equal to y or not, whether this satisfies or not. Okay, so take y to the power 4 in the left hand side, so x to the power 4 minus y to the power 4 equal to 0. Okay, so after this is the a square minus b square form. Okay, so x square plus y square into x square minus y square equal to 0, and once again x square minus y square is there, so x square plus y square x minus y into x plus y. Okay, so if we multiply three numbers and we are getting 0, then either x square plus y square equal to 0 or x plus y equal to 0 or x minus y equal to 0. Okay, so from this we are getting, and this cannot happen because if x square plus y square is 0, that means x and y is both are 0. So from this we are getting that x and y are 0, and from this we are getting x equal to minus y, and from this we are getting x equal to y. So we have two values of x and y such that fx equal to fy, and to solve this equation we are getting that x equal to plus minus y. So for two values of x, fx equal to f of y. So this is not unique, so f is not 1 1 1 1. Once again we are getting x and minus x such that after composing the function fx we are getting fx. From x we are getting fx, and from also from minus x we are getting the same value fx. This is why this is not 1 1. Next, check whether it is onto or not. So fx equal to x to the power 4, let it be y. So y equal to x to the power 4, that means x equal to fourth root of y. Okay, so if we take fourth root of a number, of a real number, we get only positive real numbers. So we have negative real numbers, that is from minus infinity to 0. These are the real numbers, this belongs to R, but there does not exist any x belongs to R such that fx equal to y and this y belongs to minus infinity to 0. So what does it mean? This means that we cannot find any real number x belongs to R such that x to the power 4 is negative real number. Okay, so fx equal to x to the power 4 is neither 1 function and it is neither onto function. Okay, so next problem number 2, check whether the relation R defined on the set H of all human beings given by R equal to xy such that x is wife of y is symmetric and transitive or not. So we have to check whether this relation is symmetric or transitive. So the definition of R is R equal to xy such that x is wife of y. So whether this is symmetric or transitive or not. So check whether it is symmetric. So we are checking symmetric. So xy belongs to R, that means x is wife of y. Okay, so this does not imply that y is wife of x, because if x is wife of y, then y is what does it imply? The y is husband of x. That implies y x does not belongs to R, and so that implies that R is not symmetric. Okay, so next check whether it is transitive or not. So check transitivity. Okay, so we have x comma y and y comma z belongs to R. Does this make any sense? So xy belongs to R means x is wife of y, and yz belongs to R means y is wife of z. So if x is wife of y, that means y is husband of x, and that y, the same y who is husband of x, can he be the wife of z? This is absurd statement. So we cannot find any y such that, so there does not exist any y, there does not exists any y such that x comma y and y comma z both are belongs to y R. So we will not find or check that x comma z belongs to R. So contrapositively, this R is a transitive relation. Okay, transitive relation. Please go through this reasoning once again. You will find something interesting to this problem and why this relation is transitive but not symmetric. So next problem number 3. For any two real numbers a and b, we define a or b if and only if sin square a plus cos square b equal to 1. Prove that R is an equivalence relation. So if you can recall that a relation is equivalence relation if it is reflexive relation, 2 symmetric relation, and 3 transitive relation. So we have to show that this relation, which is defined as a or b if and only if sin square a plus cos square b equal to 1. This is reflexive, symmetric, and transitive. So let us write the relation r equal to a comma b such that a or b means r equal to a b such that the definition is sin square a plus cos square b equal to 1, and that relation is defined on the real numbers, two real numbers a and b. So for all a belongs to real numbers r, sin square a plus cos square a be equal to 1. That means a comma a belongs to r. This is the trigonometric identity, trig identity. Okay, so a comma a belongs to r. That means r is reflexive relation. Okay, so now check whether it is symmetric or not. So a comma b belongs to relation r, and a comma b is belongs to real numbers r. So now a comma b belongs to r. That means sin square a plus cos square b equal to 1. So we have to check that sin square b plus cos square a equal to 1 or not. Does this hold or not? Okay, so we have to manipulate this equation into this form. So sin square a equal to 1 minus cos square b, that implies that sin square a equal to sin square b. So we are getting this relation sin square a equal to sin square b. Now what is the value of this left hand side? So sin square b plus cos square a. So sin square b equal to sin square a. That means we can replace sin square b by sin square a. So sin square a plus cos square a. That means 1. So we have seen that a comma b belongs to r, and this implies that b comma a also belongs to r, and that implies r is symmetric relation. Symmetric relation. So now check r is transitive or not. So transitivity. So what is the assumption of the transitivity? A comma b belongs to r, and b comma c belongs to r, and obviously a b c are from the real numbers. So what does this 2 implies? That sin square a plus cos square b equal to 1, and this implies this, and this implies that sin square b plus cos square c equal to 1. So we have to check. So to check, we are writing this. What do we have to check? So we can progress, reminding that. So we have to check sin square a plus cos square c equal to 1. So sine square a, so that means sine square a, from here we get sine square a equal to 1 minus cos square b, that means sine square b, and here it is sine square b, so we are putting sine square a here, so that means sine square b plus cos square c equal to 1. That from this we are getting sine square a plus cos square c equal to 1. So this condition is satisfied. Sine square a plus cos square c equal to 1. Okay. So this implies that a comma c belongs to R, and hence R is transitive relation. Transitive relation. So R is reflexive, comma symmetric, comma transitive. All of these three relation. That implies R is an equivalence relation. Equivalence relation. And that is proved. Okay. So next problem. Problem number 4. Prove that the function f such that n to n defined as fx equal to x square plus x plus 1 is 1 1 but not 1 2. So f from natural number to natural number, and f is defined as fx equal to x square plus x plus 1. So we are taking x and y belongs to n natural numbers, and we are equating fx equal to fy. We will check that does this imply that x equal to y. If yes, then it is 1 1. So x square plus x plus 1 equal to y square plus y plus 1. Take the whole expression in the left hand side, so x square minus y square plus x minus y, and 1 1 got cancelled, equal to 0. So that implies x plus y into x minus y plus x minus y equal to 0, and taking common x minus y from both sides, x minus y into x plus y plus 1 equal to 0. So if we two multiplying two numbers and we are getting 0, then either x minus y equal to 0 or x plus y plus 1 equal to 0. From this we are getting x equal to y, and from this we are getting x equal to y plus 1. So minus of y plus 1. So from this condition we get x equal to y, and from this condition we get x equal to minus of y plus 1. And because x belongs to natural number, that means x not equal to minus of y plus 1, because this is a negative number. So x cannot be minus of y plus 1, that means x equal to y. So we got this condition. So therefore we get fx equal to fy implies x equal to y, and this is the condition for a function to be 1 1. So that implies f is 1 1 function. Okay. Now check whether f is 1 2 or not. On to this. So fx equal to y, say. So what is fx? Fx equal to x square plus x plus 1 equal to y. Okay. So taking y in the left hand side, x square plus x plus 1 minus y equal to 0, and this is a quadratic equation. So the discriminant d is equal to b square minus 4ac, that means b square is 1 minus 4 into 1 minus y, that means 4y minus 3. And as y belongs to natural number also, because the function is from natural number to natural number, the codomain is also n, so the discriminant should be a perfect square. Otherwise, the value of this quadratic equation will be a real number. Okay, if it is not a perfect square, then the solution x equal to minus 1 plus minus root over 4y minus 3 by 2, because this is the discriminant. So if it is not a perfect square, then x will be a real number. X will be a real number, but our domain is the natural number. So if 4y minus 3 is not a perfect square, then there is no x belongs to natural number such that fx equal to y. So let us take 4y minus 3 equal to 9. Okay, that means 4y equal to 12 and y equal to 3. So if we take y equal to 4, that means what is 4 into 4 minus 3? That means what is this? 16 minus 3, 13. That means this d is equal to 13. It is not a perfect square. Okay. So for this x will be x is not a for this x is not a natural number. So we have got a number from the codomain n, that is y equal to 4, which has no pre-image in the domain x, natural number. So that implies that y is not onto function. Okay. Now next problem. Problem number 5 is saying let n be the set of natural numbers and R be the relation on n cross n defined by a comma b r c comma d if b plus c equal to a plus d for all a b c d belongs to natural number, so that the R is an equivalence relation and find a pair which related to 2 comma 5. So R is defined on n cross n. So we are taking the element from n cross n, that is a comma b and c comma d are related if and only if a plus d equal to b plus c. If this happens, then a b c d are related and a comma b and c comma d are related. And where the a b c d are coming from? A b c d is coming from the natural number n. Okay. So now check a comma a and a comma a for this is for all a belongs to natural number, whether these two are related or not. So what is the condition? That a plus d equal to b plus c, and we have take d equal to b equal to c equal to a, all are a. So a plus a, which is equal to a plus a, and both are equal to 2a. So a comma a are a comma a. This is true or holds. So that implies R is reflexive. Okay. Now symmetric, we are taking a comma b and C comma D are related. So here we have one element AB and second element CD. They are related. That means A comma B are C comma D. These two are related by the relation R. That implies that A plus D equal to B plus C. And obviously this is equal to D plus A equal to C plus B. So we are getting this thing. So we are getting D plus A equal to C plus B. That means this implies that C comma D is related to A comma B. That means R is symmetric relation. Okay. Now check R is whether transitive or not. So transitivity. Okay. So taking three elements from n cross n. The three elements are A comma B comma C comma D comma E comma F. These three are belongs to n cross n. Okay. And the assumption is A comma B related to C comma D and C comma D is related to E comma F. These are the two assumptions, and we have to show that to show A B related to E F. So we will exploit the conditions that are given. So A comma B is related to C comma D. What does it mean? It implies that A plus D equal to B plus C, and also C comma D is related to E comma F. That implies C plus F equal to D plus E. Okay. So we have to check that A comma C is A comma B is related to E comma F. That means we have to check plus F equal to B plus E. Okay. So that implies D equal to B plus C minus A. Okay. So now put this expression in this expression, that is C plus F equal to D plus E. That implies C plus F equal to D. In place of D we will put this B plus C minus A plus E. So C got cancelled and A is transferred to the left hand side. So A plus F equal to B plus C. So we get this, and this implies that A comma B is related to E comma F. So that means R is transitive, and hence R is an equivalence relation. Equivalence relation on n cross n. Okay, so now we have to find the pair for 2 comma 5. So we have to find a pair for 2 comma 5. That means 2 plus D equal to 5 plus C. So that means what is 2 plus D and 5 plus C? That means 2 plus 4 equal to 5 plus 1. This is also true. And 2 plus let 6 and then 5 plus 3, this is also true. So that means 2 comma 5 is related to 1 comma 4, and also 2 comma 5 is related to 3 comma 6, because A comma B is related to C comma D if and only if A plus D equal to B plus C. Okay, so these are the pairs which is related to 2 comma 5. You can also find other pairs which is related to 1 comma 4 or 2 comma 6 or like 5 comma 9. You can find these pairs which are related to these elements. So that's it for today. I hope you have learned something. If you have learned something, please subscribe to my channel for more videos. Thank you.